only radiation process is possible. So option number C is only the correct option. And the last question, a cotton sheet is iron with hot electric iron. How is the energy transferred to the metal base and the metal base of the iron and the sheet? So here we have the metal base, and metal is used in electric iron because metal is a good conductor of the heat. Okay, and there is a physical touch between this metal base and this sheet. Okay, and we know that in conduction process we need the physical touch. So we can say only conduction is possible in this case. So only option number A is correct. Convection is not possible because you can see this metal and sheet both are solid form and both are in physical touch. So in case of this solid, we don't need any convection process. Radiation is also not possible because there is no vacuum present in this case. And here by convection and the radiation, so this is also not correct. So only option A is correct because those are the solid, and metal is used only because it is the good conductor of the heat. So only conduction, so option number A. Now we will see the structure problems. Now we are going to start with the structured problems in the thermal physics. So first problem we can read here, solar panel is mounted on a roof of the house. Figure 4.1 shows the section through a part of the solar panel. Here this is the part of the solar panel. A pump makes water flow through a copper pipe. The water is heated by passing through the solar panel. And here the A part of the question, select and explain three features of the solar panel that maximize the final temperature of the water. So what is the use of the solar panel? Basically heating water is the use here, and we want to maximize the final temperature of the water. So we want to write down three processes, and you can see this is a schematic figure of the solar panel. The light is coming from this side. This is this particular transparent thing is nothing but the glass sheet, and we have the copper pipe. You can see painted black. This black color is very important over here. The copper is very important here. Then the glass is important. Now you have a trapped here, trapped here, and water. This is nothing but the inside. We have water. Insulating material, this part is the insulating material. So all these things are very specific, and they have been used over here for the specific reason. This is also the metal backing sheet painted black. So all these things are very important. They have been painted black. And we know there are several processes are taking place over here which maximize the final temperature of the water. We had already learned what are the conduction, induction, and radiation. So light is coming, sunlight is coming over here. This is nothing but the form of the radiation which is coming directly from the sun to the earth, and we can say this is the mode of heat transfer by the radiation. Then what is the conduction, where it takes place in the solid and the particles are fixed and they vibrate at their own position and they transfer the heat or the thermal energy to the adjacent particles. And the convection is the one where particles themselves move from the bottom to up, and the hot particle rise and the cold particle generally they fall down. So there is also the difference in the densities. So what are the different features of this figure and why the metal is used over here? We know that metal or this copper is the good conductor of the heat. So the heat is transferred to the copper by the process of the conduction. That's why the copper is used. The glass is used because glass is the good insulator, and it also traps the air. Okay, once this air is heated over here, this air is trapped with the help of this glass here. So that's why the glass is used. And we can say this black color is painted because painted black. So black is a good absorber of the heat. That's why it is painted black. So all these things, and this insulating material is used because once the heat it reached there, it should be acquired by the water and it should not be lost to the any other material. That's why the insulating material is used. So all these things are there, and we have to write down these things. Like I will start writing down. We can write down for some copper. Copper is basically the metal, and we can write down the copper is good conductor of heat. So we can write down that one point. We can also mention the copper is the uh, nothing but the metal, and all metals are the good conductor of the heat. So that can be our first point, and we can write down the black color, or black is good absorber of heat. That can be our second point. We can also write down it is a bad reflector of the heat. So that is our second point. The third point you can write down about this insulating material. What is the role of this insulating material? That basically reduce the heat loss. So we can write down over here the insulating material used reduces the heat loss. Reduces the heat loss. So in this case, heat loss is reduced, and you can write down the about the glass. You can write the three features are enough, but you can write down the extra one if you wish. I am writing down here extra just to indicate what would be the fourth one. If you want to write down in the exam, I will write down about the glass. So we can write down over here what is the use of that glass. Basically it traps this air, okay, which can be gone out through the process of the convection, okay. So we can write down the air trapping air trapping with glass prevents heat loss due to convection. So this way you can write down any 3 points you can write down. So here the air can be gone out, and that would be the convection process. And here copper is nothing but the conductor of the heat. So there the conduction process is taking place. And this insulating material also reduces the heat loss. So that is also the part of the conduction, you can say. Okay, so black is a good absorber, and here all the inside things of the solar panel are generally painted black to absorb more amount of heat. Okay, so that is nothing but the example of the radiation. So I hope you understood this part A. Now we will move towards the part B. So here is the part B of the question. During one day, 250 kg of water is pumped through the solar panel, and the temperature of this water rises from 16 degrees Celsius to 38 degrees Celsius. The water absorbs 25% of the energy incident on the solar panel. The specific heat capacity of the water is 4200 joule by kg into degrees Celsius. Calculate the energy incident of the solar panel during that day. So basically, see, the energy incident energy is nothing but in the form of the solar energy, that is in incident, and out of that only 25% of the energy is used. And once this energy is acquired by the water, its temperature is increasing from 16 degrees Celsius to 38 degrees Celsius. And the total mass of the water is given. So, and the specific heat capacity is also given, that is 4200 joule by kg into degree Celsius. So depending on the these units, this value may differ. Okay, so here it is in terms of the entire is nothing but the SI system. So here we want to calculate how much amount of energy, the total solar energy is incident on the solar panel, and the specific heat is given. The temperature is increasing. There is no change in the state. There is only the change in the temperature. So we are going to use this formula of the specific heat. So first of all, you have to write down this formula, and here for time being, I'm just going to